Hello there, welcome back to the new lecture. So in this lecture, we are going to discuss about hydraulic calculation of standpipe system by using Elite software. So let's start. So all of you know standpipe system is a type of fire protection system commonly found in building, especially high rises. It consists of a series of pipe you can see in this figure and valves that allow firefighter to connect hoses directly to a pressurized water supply within the buildings. Okay, so this enables firefighter to quickly access water to fight fire on upper floor without having to rely solely on external water sources. So basically, standpipe system are generally classified into three main types. First is class first standpipe system, then we have a class second standpipe system, and third one is class third standpipe system. So in this lecture, I will show you how to do the hydraulic calculation for class first standpipe system. Okay, so class first standpipe system, it is a type of standpipe system is designed primarily for use by firefighters. Okay, it provides water outlet hose connection. You can see in this in each and every floor we have placed the hose connection on each floor or at a specified interval along stairwell or corridors. So class first standpipe system typically deliver high pressure water for firefighting operations. Okay, here generally we have a 2.5-inch hose connection. Okay, so let's see. So before starting the calculation, first try to understand. Here our main target, we have to find out the pump flow rate, okay, system, residual system pressure and pump flow rate, na? Our main target. That is why we are doing the hydraulic calculation. So here it is written, generally in class first standpipe system, we have a 2.5-inch hose connection. You can see in each and every floor. Minimum residual pressure, how much we have to consider? 100 psi. Okay, as per NFPA 14, this detail is given. Maximum pressure at hose connection, you can go up to 175 psi. And the maximum flow required for a 2.5-inch hose connection shall be 250 GPM. From each hose connection, how much maximum flow required? 250 GPM. Okay, and minimum rate for the hydraulically most remote standpipe shall be 500. So, for hydraulically most remote standpipe, means the standpipe which is farthest from the water source, it is called as a most remote standpipe. Standpipe B is in our case it is a most remote standpipe system. So shall be 500 GPM. Here it means we have to consider minimum flow rate for hydraulically most remote standpipe shall be 500 GPM. We have to consider the two hose. Okay, because from one hose connection maximum flow rate should be 250 GPM, so 500 na for standpipe. So here I have considered two hose connection. Okay, then if you are using additional standpipe system, so for additional standpipe system, it is written here shall be 250 per standpipe. Okay, so 250 GPM we have to consider per standpipe. So that is why here I have taken only one hose connection, because from one hose connection maximum flow rate is 250 GPM. Okay, but here condition is also written for building not exceeding 80,000 square feet floor area. If your building floor area is not exceeding 80,000 square feet, on that time the minimum flow rate for additional standpipe you have to consider 250 GPM. Otherwise, suppose the floor area building is exceeding 1800 square feet, 80,000 square feet. So how much minimum flow rate we have to consider for additional standpipe? It is written 500 for the second standpipe and 250 for building exceeding 80,000 square feet floor area. For second standpipe, always you have to consider as a minimum flow rate for additional standpipe shall be 500. And if you are using another standpipe system, so for that 250. Okay, and here one more point is written for maximum flow rate shall be 1250 GPM for non-sprinkler building. Remember this thing. And if it is a sprinkler building, so maximum flow rate shall be 1000 GPM. Okay, so we are assuming our building floor area is not exceeding 80,000 square feet. That is why For additional standpipe system, we are considering only one host connection, 250 GPM. Okay, and for most remote standpipe, 500 GPM. So 2 host connection I have considered. Okay, here I have given the node name 1, 2, 3, 4, 5, 5, 6. Okay, then 7, 8. Okay, so let's start. So for that, here you have to open the first Elite software. So I am opening the software here. See, just open it. So now the software will open. After that, the first thing, would you like to see if an update? No, I don't want to see an update. Just hit on OK. Finally, first of all, now here we have to create a new project. So in File tab, hit on New. Okay. So before filling any detail, first you have to save the project. Okay. So see, here save icon is given. Save it. I want to save in desktop, so select the location from here and give the name, suppose NFPA 14 standpipe class first standpipe system. Write down standpipe system class first hydraulic calculation. Okay, here I have given the name. Getting? So we are doing the hydraulic calculation for class first standpipe system. So okay, give the name and select the location where you want to save. I think all of you know about the standpipe system. Standpipe system is a type of fire protection system. Okay, already I have discussed, commonly found in building, high-rise building. Okay, it consists of a series of pipings, valves, okay, that allow firefighter to connect hoses directly to a pressurized water supply within the building. Now save it. Okay, so here I have saved the project. Now what we have to do? Come here, see the name is written in the top also. You whatever name you have given, it is showing here. Now from here, hit on project and first you have to select the general project data. Now see, the general project data dialog box will open here. Fill the detail, project title, okay, whatever. You can write down the project title XYZ, design by engineer name. So I'm writing engineer Sajjad. Code of reference, generally NFPA 14 we are using, because NFPA 14, it is the standard for the installation of a standpipe system. Approving agency. So here I'm writing civil defense. Okay, so in this way, just you have to write down the, okay, is it clear? And here if you want to write some comment, like it is a sample project, so I'm writing sample project. Now if this data you want to include this comment, if you want to include this comment on report also, so you have to check it. Okay, otherwise unchecked. So okay, I want to include this comment. Okay, so that is why what I am doing here, I'm writing just check include this comment on report. Okay, after that come to next tab, client data. Here you have to write down the client name, address, zip code, phone numbers, then company data, company name, representative address, everything you have to fill this. Then building data, building name, building owner name, okay, contact at building. The important thing, you have to come here in system data. Okay, here inside hose stream allow, how much GPM we have to consider. When you open the Excel sheet, here you can see one hose connection, inside hose allowance is how much? 1, 2, 3. And we know that minimum means the maximum flow required for 2.5 inch hose connection should be 250. So 250 plus 250 plus 250. Okay, how much? 750. So here write down inside hose stream allowance is 750 GPM. Okay. Now come to your default pipe material. Which type of material, pipe material you are using? So hit on this drop down list. Suppose in my project I want to use the schedule 40 wet steel pipe. Select it automatically. Here you will get one number, 4 number. Now default K factor. So how much K factor? Just hit on this drop down list. Here for a standpipe system, in a sprinkler generally we are based on orific size, we are just choosing the K factor value. Normally in normal condition we are using 5.6 K factor value. Na? But here if you want to fill the K factor for hose connection, you have to select the open sprinkler K factor calculator. Okay, and already I have shown you, if you remember in Excel sheet, that minimum residual pressure how much we have to take for standpipe class, first standpipe 100 psi. So here you have to write down the minimum pressure, whatever, 100 psi. Okay, then flow rate. Here you have to write down the flow rate. So minimum, how much flow rate we have to write down? 250. Okay, maximum flow rate from each hose connection is how much? It is given here. You can see maximum flow required from a 2.5 inch hose connection shall be 250 GPM. So here write down 250. Here drop down list is also given. Here it is given. See, this is the residual pressure at the sprinkler, but we are talking about hose connection. Okay. Now see, as per that we have got the K factor 25. Okay, system has calculated. Now close it automatically. Here you will get the K factor 25. A sprinkler model, sprinkler make. So we are not designing for a sprinkler, we are designing for hose system. So just leave it this. Only here where it is sprinkler size it is showing. So just leave it. Come to your primary type of discharge. So here you have to select hose. Okay, we are talking about hose. Now write down the hose size. So we have a 2.5 inch, 2.5 inch hose diameter. So write down that diameter here. After that, hazard description. Okay. So here just take the hazard description. So it is written here one message. The hazard description constitute the maximum floor area allowed per hose discharge density. Okay, so I'm just using the light hazard. Hose system type, which type of system? Wet system. So just select that. Don't need to fill the area of flow, this all, because this we are using for sprinkler system. Okay. Now finally you have to come here in text, test static pressure, test residual pressure, test flow. So this is the city main flow test report. In city main flow test report you will get this all information. Okay. So here I am just taking from the municipality people, you will get this. Test static pressure I am assuming 210 psi. Test residual pressure here I am assuming 190, and flow test flow rate is suppose 800. Okay. Now when you enter this calculated demand pressure and calculated demand flow rate, you will get where after calculation have been performed, the program will give you the calculated demand pressure value and calculated demand flow value automatically. Okay. After the calculation you will get this value, because our main target to calculate this one only. Na? So after filling this detail, first better is to save it from here. Now again you have to come here in project. Now you have to enter, hit on enter or edit pipe data. Okay. See, now you have to fill the pipe detail. So this is our, see here I have taken the project. Okay. So we are going to start from the most remote hydraulically standpipe from 1 to 2. So from 1 to 2, when you see now, here flow is how much flow we have to consider from 1 to 2. In most remote, you know that minimum flow rate for the hydraulically most remote standpipe shall be 500 GPM. So we are talking about 1 to 2 path at node 1 to 2. So on that time we have to consider only one hose connection will come in. So 250 GPM from each hose connection, 250 maximum flow rate. So flow rate is 250 at node 1 to 2, flow rate is 250 GPM. Okay, and see, this hose connection you have to consider as a gate valve, 2.5 inch gate valve is also there. Okay, so come and fill the detail. And pipe size is how much? Okay, it is not written here. So okay, if it is not written here, I have taken the table. See, here you will get the pipe schedule for standpipe system. Okay, see, as per total flow, and total distance of piping from farthest outlet, you will get the pipe size in inches. So first tell me, your flow rate for most remote standpipe system flow rate is what? 500 GPM. Maximum total distance from the farthest outlet is how much? 1, 2, 3. Each floor height is 11 feet. So here we have a 88 feet, 1098, then plus 50, 148, then 40, 100. The total distance from the farthest outlet is more than 100 feet. So you have to open the table and see. Total distance of piping from farthest outlet is more than 100 feet and flow rate is 500. So for that, how much size we have to consider? Pipe size 6 inch. Okay. So here the pipe size which you have got is 6 inch. So write down the pipe size if it is possible. So here I am writing the pipe size for this most remote standpipe is 6 inch. Okay. In this way, you have to write down the pipe size. Now come for this one. Here in additional standpipe system, flow rate is 250. If your building floor area is less than 80,000 square feet, so flow rate is 250. Okay, it is written clearly. Minimum flow rate for additional standpipes shall be 250 GPM for building not exceeding 80,000 square feet floor area. So flow rate is 250 and pipe size is how much? Total distance of pipe from farthest outlet 88, this vertical, then 10 means more than 100. So if your pipe flow is coming between 101 to 500 only, and pipe size is greater than 100 feet, means the size is 6 inch. Okay. So here you have to write down the size 6 inch. For this additional standpipe system, same size you will get here. Okay. Now if you want to find out the pipe size for this section, from 6 to 7. So same pipe, total pipe length 40, then 10, 50. Flow rate is 750, 500 we are supplying in this one, 250 here, 750 and 50. Open the table, 750 will coming here in third row. Pipe size is between 50 to 100 feet. So it means how much? 5 inch pipe it is showing. Na? In drawing you can see 40 feet from here to here, 10 feet. So 50 to 100 feet pipe and flow rate 750. So 5 inch pipe size. Okay. So as per that you can write down the value whatever it is coming. Okay. Then finally from 7 to 8 path, how much pipe size? Total pipe length is 10 feet. Okay. And flow is 750. So 10 feet means it is less than 15 feet. Flow is 755 inch only. Okay. So here also this vertical pipe diameter is 5 inch. Okay. So in this way we have to calculate the diameter. Now let's start. So here we have to fill the pipe detail. So first of all, from node 1 to 2, one gate wall we have to consider and flow 250. Okay. So 1 to 2. What material we are using? Same material I am using schedule 14. Wet steel. So select it 4 number. Now write down the diameter of pipe 6 inch. So write down 6. Total length of that pipe is how much? So you have to see, and total length of this pipe from 1 to 2 total length, because each floor height is 11 feet. So total is 11. So write down here 11 feet. Okay. Now K factor. K factor how much we have got? Default na? So you can write type D, enter. Okay, automatically it will take 25 value. When you enter the when you type D na, so automatically they will give you the value 25. Now elevation, at what elevation you are running pipe, that detail. So come here and see. Suppose, okay, elevation, this is our, suppose here this pipe is running, elevation is 0. Here the elevation is how much? 11, 1, 2, 3, 4, 5, 6, 7, 8. From 1 to 2 node, 88 feet elevation. Okay, this hose is at 88 feet. So elevation write down 88. And node 2 elevation is how much? Node 2 elevation minus 11, 77, na? So write down that elevation. Okay. Finally, after writing elevation, flow area. Don't need to write flow area, okay? In here, you have to write down the elevation, 77. Here we don't know, na? Floor area. This you have to enter in case of sprinkler, okay? Just leave it. Here in elevation, you have to write down. Now, standard fitting. Which type of fitting? As I told you, gate valve you have to consider. Hose connection you have to consider as a gate valve. So, for gate valve, select it. Automatically, here with the help of Hazen-Williams, in software will give you this thing, equivalent length of this gate valve, 14 feet. Okay. Now, come to next. 2 to 3 parts. So, for 2 to 3 part flow rate, you have to consider 500 GPM. And here also one gate valve we have to consider for 2 to 3 part. Okay, one gate valve we have to consider. And total pipe length 1, 2, 3, 4, 5, 6, 7, 77 feet. So here I am writing 2 to 3 part. Material is same, diameter of pipe is same. Total length of pipe is now 77. Okay. And okay, elevation at node 2 elevation is 77. At node 3 elevation is now just take as a 0 elevation here. This pipe is running in ground level, let's say. Okay. So here I am writing elevation 0. Correct. Now which type of fitting we have to consider here? One gate valve is only coming. Na? So write down the detail. In standard fitting, gate valve. Okay, as per that, you will get the value. Getting 80 feet. It is showing. Whatever losses is coming as per that. Now come to next. 3 to 4. Here also flow rate is same. Only the pipe length is 10 feet now. And one elbow also you have to consider. 3 to 4. Okay. But diameter is 6 inch only. Total pipe length 10 feet. Here default value. Okay. So 25K factor which we have calculated. Node elevation. So it is at 0. Node means at node 3 elevation is 0. Now at node 4 also elevation is same 0 only. Okay, just 0 0. Then which type of fitting? Only one elbow we have to consider, this 90-degree elbow. So here write down in standard fitting elbow. As per that you will get the equivalent length. Now come to next. 3 to 4 is complete. Now 4 to 6. Here also flow rate is same. Okay. Flow rate is how much? 500. And pipe length 50, 190-degree elbow. Note 4 to 6. Okay, remember this thing. See, 4 to 6. 4 to 6. Pipe size is same, 6 inch. Pipe length is 50 feet. Okay. So this thing you have to remember. 50 and K factor value default only. Okay, 25. Note. So this all pipe is running at 0 elevation. Okay, so 0 0 elevation I have given. Now 19 elbow. So just write down the elbow. Come to next part, 5 to 6. So for 5 to 6, here also flow is 250. Pipe size is 6 inch and total pipe length 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. 88 and 10, 98 total pipe length. 98. Okay. .98. So I am writing diameter is 6, total pipe length 98 feet. Elevation. First here write down the default value. Elevation at node 5 is how much? If you remember 88 feet, no? Okay, elevation at node 5, 88 feet here, node 6, 0. So I'm writing at node 5 elevation is 88. At node 6 it is 0 only. Okay, now pressure value you will get after the calculation. Here now what we have to consider, one gate valve and one elbow, 90-degree elbow. One gate valve is coming, one elbow. So here for gate valve G and for elbow E. In standard fitting type this one, okay. Okay, see automatically you will get equivalent. Elevation at node 5, when you see in this Excel sheet, it is at 88 feet. Elevation 88 and 6 at node 6 is at 0 elevation. Okay. So I am writing here 88, 0. Okay. Then finally come to here, one gate valve and one 90-degree elbow we have to consider. So write down GE, gate valve, and for elbow E. Okay. Okay. Now next, this 5 to 6 we have completed. Come to next, 6 to 7. 6 to 7 pipe size is 5 inch. Total length of pipe 40 feet. Okay. 5 inch, 40 feet. 6 to 7 note. Material is same. Pipe diameter 5 inch. Total length you can see in Excel sheet 40 feet. So select 40 feet from here. It is default value. And this is all, elevation is at 0 level only. Okay, so just write down that detail. Now, which type of fitting we have to consider for 6 to 7? Only this T fitting. Na? One T fitting is coming. Okay. So here I am just selecting one T fitting. Okay. Then finally, when you open the Excel sheet from 7 to 8, now pipe size is 5 inch only. Total length is 10 feet. Elevation, it is going down. So let's say minus 10 feet. Okay, elevation you can take as a minus. Suppose this for this pipe. Okay, first see, I will fill this detail. 7 to 8. 7 to 8. Pipe size 5 inch. Total pipe length 10 feet. Okay. And don't need to fill node elevation. So elevation is, this pipe is running at node 7. When you see at node 7, pipe is in the ground level, means 0. At node A, the pipe is going down. Na? So minus 10 elevation you can give it. At node minus 10. Okay. Now which type of fitting we have to consider? You can see this is the discharge size. So in pump discharge size, one check valve, one gate valve we have to consider, and one this T fitting also. So here what I am doing, for gate valve I am writing this shortcut G, and for T fitting capital T, and for non-return valve what check valve C. Type C. Okay. See. Now this last, this one is your, all of you know that final node will be the inflow node. So because flow will in from here only, select the final node, hit on mark inflow node. Okay. So finally now come to here, one icon, calculation icon is given, hit on calculation icon. We have to do the calculation. In calculation mode, first you have to check the demand. So we know that minimum residual pressure at hydraulically hosed node is 100 psi. Okay. So just that you have to enter that detail. And for light hazard we are considering, so 0.1 GPM per minimum desired density. Now imbalance. Here the maximum nodal pressure should be less than 0.01. So I am using 0.001. Let's say. Okay. Initial damping factor. It is written all systems should be started with a damping factor of 4 or greater. So I am assuming 4. Minimum damping factor. Most nominal pipe network systems should have minimum damping factor of 1 to 2. Okay, so assume 1. Okay, then hit on calculate. Here you will get one message. You need to specify the maximum area per sprinkler or area of sprinkler operation. Okay. We have not specify the maximum area. Na? First we have to specify the maximum area also, because in case of but here actually we are doing standpipe system calculation, so don't need to write here any GPM, just 0 only. Now hit on calculate. Okay, see here you will get the result. Actually what happened here in calculation, I have given the value of density. So we are not designing for sprinkler system, okay? We are designing for standpipe system. Don't need to give the density area. When in case of a sprinkler, we are just doing we are entering okay? So here don't need to come here in solution. You will get, see, demand residual pressure at system inflow node is 179 showing, and demand flow at system inflow node is showing 1959.20. Okay, this is your demand flow at system inflow node. But you know that I have shown you one message, if you remember. Maximum flow rate shall be 1250 GPM for non-sprinkler building. If your maximum flow rate is coming more than 1250 GPM for non-sprinkler building, so then also you have to consider this value only. Don't go beyond that. If it is a sprinkler building, so maximum flow rate shall be 1000 GPM. Okay, remember this case. In calculation, it is coming 1959, but we have to consider 1250 only. Okay, and pressure, demand residual pressure is showing in 179.154. Okay, and here I have given, it is written that maximum pressure at hose connection should be 175 psi. Now suppose hit on calculate. Okay, so calculation is done. You want to print, hit on report, quick print report. In the name list, select Microsoft print to PDF. Okay, now see the print is started. Now you can save it in desktop with the name NFPA. Same, I want to give this name. Okay, NFPA 14 class 1 hydraulic calculation. Save it in desktop. See, the file is saved. Now if you want to open that file, so you have to open the desktop. From the desktop you will get that file, NFPA standpipe system class 1. See, fire hose system report. Just scroll down, general project data report. Here whatever you have filled, then description of hazard, hose system type which you have selected, hose K factor, whatever value it is given here. Okay, test flow rate, whatever we have taken, as per that the system give you the value. Just scroll down, here you will get the final is given here. Average hose flow 279 point hose flow. Okay, then overall network summary is given here. You can see demand flow at system inflow node and minimum required residual pressure system inflow node is 175 psi. You can try to understand this hydraulic supply demand curve. Okay, in that finally here it is given. Okay, this is our main target, to calculate the calculated residual pressure and calculated flow rate. Okay, in this way we have to do the hydraulic calculation. But remember, in our case it is coming flow rate 1959, but it should not be greater than 1250 GPM in case of non-sprinkler building. And calculated residual pressure should also, maximum you can go up to 175 psi. It is written here as per NFPA. Maximum pressure hose connection should be 1. So you have to consider as a 175 psi. Okay. So in this way, we have to do the hydraulic calculation for standpipe class first standpipe system. Same procedure you have to follow for the class second. In class second, generally we have a 1 or 1.5 inch hose connection. You have to follow the same procedure for that. Okay. I hope all of you enjoy this session. See you in next one.